Okay, today we're going to continue talking about our trigonometric identities, and we're looking at verifying identities. We've looked at this a little bit in class, and we'll continue to build on this. And I think some of you have encountered some frustrations. I just want to help clear up some of those. Anytime we're asked to verify trigonometric identities, we want to make sure we follow, there's a few steps we can go through to maybe help us out. Now, this isn't a recipe that will work on every problem. It's not necessarily an algorithm of things that you're going to do in every problem. As you'll see, each problem is different, but there are certain things that we can look to do every time we encounter one of these, and usually you can find something in there that's going to help you get started with it and find parts that will work. The first thing we always want to do is we want to start with the side that seems most complicated. Sometimes that'll be really easy to point out. Other times it might be difficult to tell which one is more complicated than the other. At that point, it's really just a call on either way. You can work with it, whatever you feel most comfortable with. It might be looking at the side that shows you something that you see first over the other side. But whatever you're going to do is you're going to want to pick that one side, you're going to work with it, and you're going to try and simplify it out or adjust it so that it becomes exactly equal to the other side of the equation. Once we start picking what side we're going to, or once we have picked what side we're going to work on, we'll then look to use basic identities that we've already learned. These are our reciprocal identities, our quotient identities, and our Pythagorean identities. Hopefully you're well versed in those at this point. We spent a lot of time talking about those in class. If you are not familiar with those right now, I would strongly urge you to take some time, maybe pause this video, go back and look at them, maybe get out your notes and make sure you have some way of being familiar with those as we go through this. If you are not familiar with the basic identities, your reciprocals and your quotient identities and your Pythagorean identities, you will have a difficult time getting these done because everything we're doing is based off of those. So we're going to look to use those anytime we get a chance. If we have fractions in the problem, we'll look to combine the fractions anyway, whether we add or subtract them. And remember that we do that by finding the least common denominator of both fractions and adjusting so that we have a common denominator so that we can combine them. I know sometimes we forget to do that, even though we know that that's a fundamental part of adding fractions. If we have something that does not necessarily work with any of the basic identities that we have, we are aware that the Pythagorean identities contain squares and ones and things like that. In order to get those, sometimes we might want to multiply a conjugate to create one of those Pythagorean identities. We'll multiply a conjugate to the top and bottom of a fraction to create a situation where we do have a Pythagorean identity. We'll look at some examples where we do that later on. Another method might be to look to factor out any GCFs or any polynomials or any polynomial expressions that you see there. You might want to look to factor out and set up so that we can pull out some of these identities that we're already familiar with. And whenever you get stuck and we don't see anything else to do, make sure you stop and convert everything to sines and cosines. Get your cosecants to be 1 over sine, and get your tangents to be sine over cosine, etc., so that everything is in the same terms, and that way sometimes we can see things that cancel each other out a little bit easier when we do that. So if we get stuck and we don't see any of the identities to use, always try and use that as a last resort to make sure you're getting things that might be able to be combined otherwise. Number one thing you want to make sure is you don't get frustrated. Very easy to look at some of these and say, man, that just looks impossible, I can't do that. Some of these will look very hectic. There'll be lots of different things going on within them. The main thing is to just find what you can do, focus on it, break it down piece by piece, and eventually you'll see that it's not nearly as complicated as you may have initially thought. With that said, let's go ahead and jump in to some examples. We'll look at our first one here. have cosecant squared x minus 1 over cosecant squared of x. And we're going to verify as to whether that is equal to cosine square of x. So the first thing we're going to do is we'll identify which side seems most complicated. Looking at this real quickly, you can probably see that this left-hand side of the this equation to verify is a little bit more complicated than the right-hand side. So then we're going to begin to look to use some of our basic identities that we may have. Well, I don't have a specific identity that states anything about cosecant of x minus, or cosecant x squared minus 1, but I do have an identity that says 1 plus cotangent squared of x, see if I can make an x, is equal to cosecant squared of x. Now, that's not exactly what I have there, but we can rearrange this identity to say what we need it to say. So I can actually subtract 1 off of both sides, and I'd have cotangent squared of x is equal to cosecant square of x minus 1. And that is what we want to use. So we're going to come and rewrite this left side by using that expression. So instead of this cosecant square of x minus 1, we're just going to call that cotangent square of x. So we've got cotangent square of x over cosecant square of x. Now, the property that allowed me to do that was the Pythagorean identity. So I'll label that next to my work to kind of verify my reasons there. I've used the Pythagorean identity to change cosecant square of x minus 1 to cotangent square. Now, once we get to this point, we might not see anything else to do. So we don't have any fractions to combine. We only have the 1 there. We don't really need a conjugate or anything. That's not really going to help us in this step. Nothing to factor out, so we're kind of stuck. So what we're going to do is we're going to convert everything to being in the form of sines and cosines. So let's look at this now, and we can change cotangent square can be rewritten as cosine square divided by sine square. And of course that's divided by the cosecant square that was already down there. Now, changing cotangent square to cosine square over sine square is one of the quotient identities. And that gives us something that's going to be able to work with a little bit more when I do the same thing with the cosecant. Now, cosecant squared, and let me write this in because we've got this now, cosine squared x over sine squared x divided by cosecant squared can be rewritten as 1 over sine squared of x. Now, that is not the quotient identity, that is called a reciprocal identity. Okay, so the cosecant and sine functions are reciprocals of one another. So if we have cosecant squared of x, we can rewrite that as 1 over sine squared of x. Now the next step might be a little more obvious to you at this point. We have two fractions that are being divided. We can divide them, and the way we do that is simply to flip the second one over and multiply. So we have cosine squared of x over sine squared of x, and then I'm going to bring this part off of the bottom and we're going to multiply it after we flip it over. So we have sine squared of x over 1. That is the rule of division of fractions. That's all it is. It's just simple division. That's what we're doing there. Nothing fancy. Continuing that, you can see as we multiply this, some things will cancel out and we'll simplify it out. and what will be left would be cosine squared of x. Now, we were trying to verify, and I didn't write it all the way down, but we were trying to verify that it was equal to, in fact, cosine squared of x. So we've completed the problem by showing that both sides were equal to each other. Cosine squared of x equals cosine squared of x. Now, my reasoning for that, you can call it division, you can call it multiplication. I'm going to write multiplication here because we were multiplying the fractions and they canceled out. But it's all division, multiplication. It's pretty much the same thing, as you will know by this point. All right, now here's another example. We're going to verify that tangent squared of alpha is equal to secant alpha, cosecant alpha, tangent alpha minus 1. Again, we want to kind of go by these tips. Start with the side that seems the most complicated. And looking at this one, I see that this side, or over here on the right side, seems a little bit more complicated than the others. So we're probably going to want to work with it. As we continue to look at that, the next thing we would want to do would be look to use basic identities. Well, I don't see any basic identities already kind of posted there. I do have a minus 1, and that kind of makes me think about some Pythagorean identities, but I don't really have anything there that's going to lead to one on that right side anyway. So we're going to kind of continue down the list. We'll combine fractions. We don't have anything like that. We don't have any multiplying or conjugates. Not going to really do anything. Factor out GCFs and polynomials. If you look at this, whoop, that's the wrong way. If you look at this one, there's no GCFs really in this list of factors. They're just all kind of being multiplied together. It would be nice if we could factor something out, but unfortunately that doesn't really work as it is. So we're going to just kind of continue on down the line, and we will look at this. We're going to go ahead and change everything to being in terms of sines and cosines and see what that gets us. As we do that, we'll go ahead and convert our secant of alpha. That is 1 over cosine of alpha. And at the same time, I'm going to go ahead and do the cosecant of alpha because that is 1 over sine of alpha. Now, I'm doing both of those changes, or I'm using one rule to make both of those changes, and those are the reciprocal identities. I'm just going to kind of abbreviate there, but you get the point. So as I do that, I can kind of continue along with this same method when I look at tangent of alpha. Tangent of alpha can be converted as well. I've already got 1 over cosine alpha. That's just bringing down 1 over sine of alpha. I'm going to take tangent of alpha, and I'm going to change it to sine of alpha divided by cosine of alpha. Now, that is not a reciprocal identity, but again, that is a quotient identity that allows me to make that statement. So we'll make note of that there. And as we continue, we can look to combine all of these either by multiplying or adding or subtracting or whatever we need to do. In this case, the 3 fractions here can be multiplied together. And we multiply fractions straight across the top and straight across the bottom. So that would be sine of alpha, 1 times 1 times sine, times, or over, cosine squared of alpha. That's cosine times sine of alpha. Now, that actually works out pretty nicely. And we'll look at that in just a second, but what I did there was just some straight multiplication. So we'll make note of that there. So somebody that walked up could read this and say, oh, well, they multiplied in that step and that's how they got there. So our next step is to identify the fact that these signs can cancel each other out. So that would leave us with 1 on top and cosine squared of alpha on the bottom. That ends up being just division or simplifying a fraction, whatever you choose to call it. That's division. And you might see something here, you might not. If I don't see anything, I'm going to go back and look at the fact that I can maybe subtract these if I don't see this step. And I'll come back and mention what it is in a second. But there is something we could do here that would maybe be a shortcut. I'm just going to kind of put an asterisk here and say we can come back to that and look at it in a minute. If I want to add these or combine this fraction with 1, though, I have to get a common denominator. So my next step would be to change 1 so that it has a common denominator, and that would be cosine squared alpha over cosine squared alpha. And that is just finding a least common denominator. We might want to make note of that there. So now I have fractions that can be combined. And if you go back to your list, that is one of the steps that we want to go through. Once we get this done, we just kind of want to start back up at the top and start going back through. We're going to combine fractions. We'll find the least common denominator and add or subtract. So we just found the least common denominator, and when we add or subtract, that's going to give me 1 minus cosine squared of alpha over cosine squared of alpha. And that is just subtraction. Now, continuing along, I'm going to make a little extra space here. 1 minus cosine squared of alpha, hopefully you're becoming familiar enough with these identities to realize that that is a modification of the Pythagorean identity. The Pythagorean identity is sine squared plus cosine squared equals 1. Well, we can modify that a little bit, and we get that 1 minus cosine squared of alpha is sine squared of alpha over the cosine squared of alpha that was already there. Now, again, that is using a Pythagorean identity. I'm going to abbreviate just to save a little time here. And sine squared of alpha over cosine squared of alpha is tangent squared of alpha. And that is what we were trying to prove everything was equal to. So we have completed our identity, or verifying the identity. That last step was done by using a quotient identity. Now, you heard me mention up here at the step above, let's see, at this step above, that we were able to modify this, or we could have maybe done this a little differently. Another way of doing this would be to write cosine squared as secant squared alpha minus 1. And knowing your Pythagorean identity, that does lead to getting tangent square of alpha. So you could have maybe taken that approach with that problem and done it a little differently than you did in that problem, or than I did right there. But either way, you're going to get the same solution. It's just that one might have gotten you there a little bit faster. Not that it was right versus the other one being wrong. It's just a different way of doing it. So we finish up with the quotient identity here, getting tangent squared alpha equal to tangent squared of alpha. All right, our next identity to verify is cosine of alpha over 1 plus sine of alpha plus cosine of alpha over 1 minus sine of alpha equals 2 secant of alpha. And again, we want to start off by identifying the side that maybe appears a little bit more complicated than the others. So we're going to obviously probably work on this left side here. It seems quite a bit more complicated than the right side, so we'll start working on that. Now, going through our list of options as to what we might want to do, we want to start with the side that seems most complicated. We got that done. Look to use basic identities. Well, if you look at this, there aren't really any basic identities there. We have 1 plus sine of alpha and 1 minus sine of alpha. That kind of leads us to believe there might be some Pythagorean identities in play later on down the road, but here we don't really have them as they are. So continuing that, we don't really have that there. Combined fractions, finding the LCD and adding or subtracting is something that we could definitely do in this problem. So we're going to go ahead and try that. Now as I look at these, my common denominator is not going to be a pretty one. It's going to be 1 plus sine of alpha, 1 minus sine of alpha. And it actually works out pretty nice for us, and we'll talk about that in a minute. But that's 1 plus sine of alpha, 1 minus sine of alpha. That is the common denominator, and I'm just going to mark that over here. This is the step that we're doing. This is the reason that we're doing it. It's the least common denominator step. All right. This fraction already had cosine of alpha, and it had 1 plus sine of alpha on the bottom. So to get it to be this, I'm going to multiply another 1 minus sine of alpha. And this is just simply getting the bottom to come out like this. I have to multiply that on the top. Over here, I had 1 minus sine of alpha to begin with, so we're going to take the cosine of alpha that was there, and we're going to multiply 1 plus sine of alpha to both sides, or both the top and the bottom. And this is how we get to this step. Now, once we get here, we have common denominator, so we can begin to add. Before I do that, though, I am going to do some multiplication. On the bottoms, if I multiply these bottoms, and you can maybe just do a little scratch work here and do the FOIL method, you'll see that we get 1 minus sine squared alpha. And maybe you remember the product of a sum and a difference, or the product of two conjugates gives you a difference of squares. So this is 1 minus sine squared alpha, and that is something that's really nice. Now, on the tops, I still have this cosine alpha, 1 minus sine of alpha. If we want to, I guess I could probably go ahead and do this in one step as well. I'll go ahead and multiply that through. As we multiply that with the distributive property, that's going to be cosine of alpha minus sine alpha cosine alpha. And then if I do the distributive property over here, I've got cosine alpha plus cosine alpha sine of alpha. Now again, that's just distributive property. On the bottom, we just did some multiplication too, so this is all multiplication in this one step. We could have written that in two separate steps, however, we're just going to do it all at once. So now we can add the fractions. As we add, I have cosine plus cosine, that would be 2 cosine alpha, minus sine alpha cosine alpha, and plus cosine alpha sine alpha. Those cancel out. And I've got 1 minus sine squared alpha on the bottom. Now, that step again was just done by addition. We were adding the fractions. And remember, to add fractions, you just add the numerators and keep the denominator the same. Now, there's something special about this denominator, and hopefully you've been thinking it all along, you've seen it, and you're saying, man, he's missing that. We can go ahead and do that, and you might already see what needs to be done. 1 minus sine squared alpha is a variation of one of our Pythagorean identities. Sine squared alpha plus cosine squared alpha equals 1, and we can modify it to say 1 minus sine squared alpha equals cosine squared of alpha. And I'm getting a little lag in my screen. Hold on one second. Come on. There it goes. Cosine squared of alpha on the bottom, and we have 2 cosine alpha on top from before. So the reason for that is a Pythagorean identity. Okay, and we're almost done. As we write 2 cosine alpha over cosine alpha, cosine squared alpha, that simplifies. The cosines cancel out, so I have 2 over cosine squared alpha. Now that's just division or simplification, however you choose to say it. And then we can use a quick method. Going back and looking what we wanted to get it to, we want to get it to be 2 secant of alpha, and we have 2 over cosine of alpha, or I should have cosine of alpha, not cosine squared, excuse me. we can realize that that is just a quick modification, because 2 over cosine alpha would be equal to 2 secant alpha by the reciprocal identity. So we've got 2 secant of alpha equals 2 secant of alpha, and we're done. That is our final step. All right, our next example is a little more complicated. Actually, it's a little more complicated on both sides. You have sine of alpha over 1 minus cosine of alpha, and we want to verify that that's equal to cosecant of alpha plus cotangent of alpha. Again, we always want to identify which side is a little bit more complicated to start off with. However, in this particular case, as we look at this, we might say, well, I don't know which one's more complicated. Well, it's not something we want to lose a lot of sleep over. We're going to have to do it at some point anyway, so we're just going to jump in and start working with one of the sides. I'm going to take, since fractions tend to be a little bit more complicated anyway, I'm just going to start off on this left side and work with it and go through the steps that we would normally look for and see what we can do. And if that ends up being the wrong way, we would go back and work to the right. However, I think that this one will work a little bit better for us. So as we go through, we find the side that seems to be most complicated. We've said it's going to be the left. Doesn't really matter which side you pick. We're going to look to use basic identities. As we look at this, I don't really see any basic identities in place. No Pythagoreans to be used right off the bat or anything like that. Again, I have 1 minus cosine alpha here, but it's not really something that is a Pythagorean identity as it is. So we go back to our list. We combine fractions using the LCD and adding or subtracting. I've only got 1 fraction here, nothing to combine. So we continue on down. This is where I want you to pay attention to what's going on. Multiply a conjugate to create a Pythagorean identity. As we said, 1 minus cosine of alpha is not a Pythagorean identity. However, it's very close to being one if it had another piece there. So what I'm going to do is take this sine of alpha and 1 minus cosine of alpha, and I'm going to multiply this fraction. I'm going to put it here, and I'll put it in blue just to show it's different. I'm going to multiply this by 1 plus cosine of alpha on the top and the bottom. Now this is multiplying a conjugate. It's a process that creates a difference of squares on the bottom, and that would come in very handy here for us as we continue to work with this. Now I'm going to make note that that's what I'm doing, multiplying a conjugate. Okay, that's completely within the rules of what we're doing. We can do that. All right, so as I do this, my top is now going to be sine alpha times 1 plus cosine alpha. Let's see if I can write cosine. And the bottom is going to be 1 minus cosine squared alpha. Now again, you can go through that process of doing the FOIL method if you like, if you don't believe me. Hopefully by this point you're becoming familiar enough with this to know that if I do the FOIL method and multiply all these pieces out, that's what I'm going to get there. I get a difference of squares, which is what we've created. That was the purpose of doing it in the first place. So this step is just multiplication again. Multiplication. And the nice thing about that is that 1 over cosine squared is something that we can use here. 1 over cosine squared is sine squared alpha. So that is a Pythagorean identity. All right. Now, as we do that, we have sine over sine squared. We can cancel out factors in a fraction. That's called simplifying or dividing. So I am now left with 1 plus cosine alpha, and I'm dividing that by no longer sine squared, but just sine of alpha. That's just division. All right, and looking at this and looking where we want to go. Now we have 1 plus cosine over sine. Now we want to get cosecant, which is 1 over sine, and cotangent of alpha, which is cosine over sine, from this. So I can easily break this apart into those pieces. So I can get 1 over sine of alpha plus cosine of alpha over sine of alpha. And now the only reason I did that was because I knew where I was going. So sometimes it's a good idea to look back at what you're actually trying to get it to decide what you're going to do. Now, all that is just addition or breaking apart an addition problem. I'm just going to call it addition, basically because we're just rewriting the addition problem. And as we look at that, 1 over sine of alpha is the reciprocal identity for cosecant of alpha, plus cosine over sine of alpha is cotangent of alpha. Now what I'm actually doing there, I probably should break this in 2 steps. We'll let it slide here because they're very similar things. What I'm doing to write this as cosecant is the reciprocal of identity, or what I'm using to do that. Now, what I'm doing for this step is using the quotient identity. So I'm going to combine them all at once because I am running out of space here at the bottom, but you get the point that that is 2 separate steps. Basically, I've just kind of combined it into one, and it's fine if we do that, but we do need to make note that we used both of those there. And we have completed this problem. We have cosecant alpha plus cotangent alpha equals cosecant alpha plus cotangent alpha. Okay, so we're going to take one more. I do want to show you one more technique that we can use and let you know a scenario where you would use it. As we go through this list, we want to start with the side that seems most complicated. We've obviously, hopefully got that understood by this point. Looking at this one, it's pretty obvious the left-hand side of this verifying identity, or the identity to verify, is more complicated. So we'll look at that, and we've got that picked. Look to use basic identities. Looking at this, there is not really a basic identity in here. You see there's a cotangent to the third, there's cosecant squared, there's a lot of other stuff going on there. We may be able to get something out of it down the road, but we don't really have anything there as it is. So we don't have that. Combined fractions, there are no fractions there. Multiply conjugate, not really an option. We don't have something that's close to being a Pythagorean identity like that. What we want to look at is to see if we can factor out any GCF or maybe a polynomial in this equation or this identity to maybe simplify some things. Now, as I look at this, we can see that there is a cotangent in both pieces. There is a secant in both pieces as well. So I can begin to take those out as a GCF. I can rewrite this as cotangent theta, secant of theta. And when I take those out from this expression on the left side, that leaves me with cosecant squared theta minus cotangent square theta. Yes. Just wanted to make sure I was saying that right. Okay, so I've taken out the cotangent, or one of the cotangents, and the secant out of both of those terms. My method there, or my reasoning behind that step is I'm using the GCF. Okay, I'm just factoring out a GCF. Now, the advantage in doing this is that if we look at cosecant squared minus cotangent squared. It's not necessarily one that you would see very often, but there is a Pythagorean identity that involves those two. And if we are, at least acknowledge that, we can take a look at that identity. It's 1 plus cotangent squared equals cosecant squared. Now, I can rearrange this by subtracting this from both sides, and that would give me 1 is equal to cosecant squared minus cotangent squared. And this is what I'm looking to use in my problem. So we're going to go ahead and see if we can rewrite this now with that being used. So what I'll do in my next step is I will say that cotangent of theta, secant of theta, is being multiplied by 1. And that is a Pythagorean identity. Now, once we have that, we're trying to get it to be cosecant, and we have some things that might make us start thinking that. So at this point, not a lot to do. We would just kind of continue down the list. We don't have anything else to do except go ahead and start converting everything to sines and cosines. So that's going to be what I'll look to do next. I can rewrite cotangent of theta as cosine of theta over sine of theta, and I've got secant of theta. I'm going to go ahead and do this like so. That would be done by the quotient identity, and then in my next step I've got secant of theta, and that could be rewritten as 1 over cosine of theta. Now, that is the reciprocal identity. Again, you can see, if you're not familiar with these identities, the basic identities, you're going to really run into some difficulties here. So make sure you take some time and know those if you don't already. Cosine over sine times 1 over cosine, as we multiply that, we'll get 1 over sine, and that is just multiplication. You can call it multiplication and division. And I'm actually dividing out the cosines there. The cosines cancel, hopefully you see that. And looking again, we wanted to get the cosecant squared, or cosecant theta, so we're going to finish it out right here. Cosecant theta equals cosecant, making a mess, cosecant theta. At the bottom of the screen it's difficult to write. All right, so I've got cosecant theta equals cosecant theta, and that was the reciprocal identity. And we are done. They're both equal to each other, and we have verified it. Again, that's the last of the examples for now. Hopefully you've had a few examples to kind of get your feeling on these right, and to see the different methods and techniques that you can apply. Main thing, again, don't get frustrated. Always remember there's usually more than one way or more than one method that's going to work. The best thing you can do sometimes is just keep playing around with the different pieces of the puzzle. Try this over here, try to work on this side, try to work on this side, maybe go back and try it again and see what works. Eventually, after you keep playing around with things and applying the different identities, different techniques, you're going to find something that's going to make it be seen by you. You'll be able to see it and cancel out some things that will get you to where you want to go. Most of these, when you look at them initially, they're going to appear intimidating. They're going to seem like there's no way that it would come out to equal what you've got to get it to come out to equal. Just relax, stick to what you know, and try and work your way through it. It's the best advice I can give. Again, there's not one way to work every problem. They all work out in different ways. Many of you know I'm a Star Wars fan. Master Yoda said it best, you will know what you need to know when you're calm and at peace. You get upset and you get frustrated with the problem, you kind of have a tendency to shut your mind down, and you're not ever going to see what you need to see. So try and keep cool. If you get frustrated with it and you don't see it, maybe just take a break from it, work on another problem, and come back and try it again. A lot of times you'll see what needs to happen.